Our project is global warming, TigerGraph with machine learning. Every point of degree matters. At the rate we are going, we got around 10 years until we hit 1.5 degree. Intergovernmental Planet on Climate Change (IPCC) finds that limiting warming to 1.5 degrees Celsius requires global emission to be slashed by 45% by 2030. It is very unlikely that we'll manage to limit warming to below 1.5 degree without overshoot. That extra 0.5 degrees Celsius, according to the IPCC, is expected to impact an extra 10.4 million people. Why we need this solution? Global warming is a very critical challenge. We humans are the ones who burn fossil fuels and chop down forests, causing average temperature to rise worldwide. As part of the solution, I created a two-stage approach to combine TigerGraph with machine learning to help track, understand the relationship, and highlight any anomalies in this overall trend. So as part of the challenge, started with 4 datasets with monthly granularity, but the idea is to use this approach for real-time, permanent, hourly, or daily datasets. Forecasted values from the machine learning model can be used to understand any anomalies in carbon emissions, temperature, ocean heat, ice extent by comparing against actual capture values, as it's very critical to understand if we are heading in the right direction or not. How TigerGraph with machine learning can help. Stage 1 started with the 4 different datasets. Those are the time series datasets I use, mainly focusing on the carbon emission, temperature anomalies, ocean heat, and ice extents. How TigerGraph with machine learning can help. Stage 2. Use TigerGraph as a data source to regression model post understanding relationship between different data points mentioned in Stage 1. Model 1 time series to focus predict carbon emission based on historical data points. Model 2. Build regression model with carbon emission as independent variable and temperature, anomaly, heat. I'm showing you how I created the TigerGraph using the notebook. So here you can see that I inputted the required libraries, created the vertex, edges, and connected to TigerGraph, uploaded the files, created the job to upload the data, and then created the queries to add some months, created the query to extract some data as well. For more details, you can refer to this, but post execution, I can see this whole schema got created. You can see updated to the graph. The data is already loaded into the graph as well. You can see all those data points here. And I created queries to extract and manipulate the data as well. Now it's time for a demo. As you can see, I created a Python program to build the machine learning model. It's connecting to the TigerGraph actually and fetching all the requirement from it. So I'll just quickly show you the demo of it by executing it. So over here I can see the flags which I want to forecast. I'm just going to run this out. I should fetch the data from TigerGraph for the required parameters. Gonna build the regression machine learning model on it, and based on that, gonna forecast on it. So over here you can see it's connected. It's connected to global climate change data, and now it's doing the processing in the background as it's a machine learning model. It's gonna take some time to build it. It's learning it. It's starting to forecast the carbon emission. Once it's done, yeah, as you can see, the parameters are chosen. The root mean square error is 1.5, so this is what the value looks like. Actually, it's predicted for the carbon emission. Time series forecasting. If I close this, and this is what the value looks like for the ice extent forecasting. You can see this is what the value looks like for the temperature anomaly, and so on. And over here you can see the correlation variance and root mean square error value for each of these, showing quite accurate.